You are listening to Laravel, crafting modern web applications. Subscribe to keep up to date on our latest audiobooks. Laravel, crafting modern web applications. A new era of web development. Welcome to Laravel. Web development, in essence, is about creating the digital spaces we interact with daily, from social media platforms to online stores and educational portals. For many decades, the landscape of web development has continued to evolve, each iteration bringing new tools, methodologies, and philosophies. Among the most transformative advancements in the PHP ecosystem is the Laravel framework. For some, the mention of PHP might conjure images of old, unmaintainable websites. However, just as the internet itself has matured, so too has PHP. Today's PHP is a performant, robust language, powering a significant portion of the web. Leading this resurgence is Laravel, a framework that not only embraces modern PHP, but elevates it, offering developers an elegant and efficient toolkit to build cutting-edge web applications. What is Laravel? More than just code. Laravel is an open-source PHP web framework created by Taylor Otwell, designed for the development of web applications following the Model View Controller (MVC) architectural pattern. Launched in 2011, Laravel quickly gained immense popularity, distinguishing itself from its contemporaries with its focus on developer happiness, elegant syntax, and a robust set of features out of the box. Think of Laravel not just as a collection of libraries, but as a well-organized factory floor for building web applications. Instead of starting from scratch with raw materials, just PHP language constructs. Laravel provides the machinery, the assembly lines, and even some prefabricated parts. This allows developers to focus on the unique aspects of their application, rather than reinventing the wheel for common tasks like database interaction, routing, or authentication. A brief history of web development and PHP's role. To truly appreciate Laravel, it helps to understand the journey of web development. In the early days, websites were largely static HTML files. If you needed dynamic content, like a counter or a guestbook, you'd integrate simple scripts, often written in languages like Perl or rudimentary server-side includes. PHP emerged in the mid-19s as a simpler alternative for creating dynamic web pages. Its personal homepage origins meant it was designed for easy embedding within HTML. This simplicity was a double-edged sword. It made PHP accessible, leading to its widespread adoption, but also contributed to a reputation for disorganized, spaghetti code as projects grew without proper structure. As applications became more complex, developers sought better ways to organize their code. This led to the rise of framework-structured collections of code that provide a foundation for building applications. Early PHP frameworks started bringing order, promoting patterns like MVC. However, many were either too prescriptive, too lenient, or simply lacked a truly elegant developer experience. Enter Laravel. Taylor Otwell, its creator, famously said he built Laravel because he didn't like the alternatives. He envisioned a framework that was both powerful and a joy to use, putting the developer at the center. Instead of fighting the framework, developers should be productive and enjoy the process. This philosophy permeates every aspect of Laravel, from its clear documentation to its expressive syntax. The problems Laravel solves. Before frameworks formalized the development process, building a significant web application often meant repetitive tasks, writing the same code for input validation, database connections, or security measures for every project. Inconsistent structure. Different developers on the same project might organize code differently, leading to confusion and maintenance nightmares. Security vulnerabilities. Manually handling security measures is prone to error, leaving applications open to attacks like cross-site request forgery, CSRF, or SQL injection. Time-consuming development. Much effort was spent on foundational plumbing rather than the unique features of the application. Laravel addresses these issues head-on by encapsulating common tasks, providing ready-made solutions for routing, database access, authentication, caching, and more. Enforcing structure, guiding developers to organize their code logically using the MVC pattern. Prioritizing security, implementing robust, built-in security features by default, making secure coding easier. Accelerating development, allowing developers to ship features faster and with greater confidence. Key features and benefits of Laravel. Laravel's popularity stems from a suite of carefully crafted features that collectively enhance the developer experience and the quality of the resulting applications. Eloquent ORM, Object Relational Mapper. This is perhaps one of Laravel's most beloved features. Eloquent makes database interaction incredibly intuitive. Instead of writing complex SQL queries, you interact with your database using expressive PHP methods and objects. For instance, to find a user by their ID, you might retrieve an object representing that user rather than formulating a direct database query. It abstracts away the database specifics, allowing you to focus on your application's data models. Blade Templating Engine. Blade is Laravel's powerful yet simple templating engine. It allows you to use plain PHP in your views while providing convenient shortcuts for common tasks like displaying data, looping through arrays, and conditional rendering. Its primary goal is to keep your view code clean and separate from your application logic, making your templates easier to read and maintain. Artisan Console. Artisan is Laravel's command line interface. It's a developer's best friend, automating many repetitive development tasks. With Artisan, you can generate boilerplate code, like controllers, models, migrations, run database migrations, clear caches, perform unit tests, and much more, all without leaving your terminal. This significantly speeds up development and reduces manual errors. MVC architecture. As mentioned, Laravel adheres to the model view controller pattern. Models represent your application's data and business logic, often interacting with your database via Eloquent. Views are responsible for presenting data to the user, usually HTML generated by Blade. Controllers act as the intermediaries, handling user requests, interacting with models, and selecting the appropriate view to display. This separation of concerns makes applications more modular, testable, and easier to scale. Routing system. Laravel's routing system is powerful and intuitive. It allows you to define clean, human-readable URLs that map directly to your application's logic. You can define routes for web pages, APIs, and even command line tasks. Authentication and authorization. Security is paramount. Laravel provides robust, full-featured authentication and authorization systems out of the box, making it remarkably simple to implement user registration, login, password resets, and role-based access control. Package ecosystem. Laravel fosters a vibrant ecosystem of official and community-contributed packages. Tools like Laravel Livewire for building dynamic interfaces with PHP, Laravel Nova, an administration panel, and Laravel Passport for API authentication extend the framework's capabilities, allowing developers to leverage existing solutions for common problems. Who uses Laravel and for what kind of projects? Laravel's versatility makes it suitable for a vast array of projects, from small personal blogs to large-scale enterprise applications. Startups and SMEs. Its rapid development capabilities allow new businesses to quickly build and iterate on their products without extensive development time or cost. E-commerce platforms. Many online stores leverage Laravel for its database handling, payment integration capabilities, and robust user management. Content management systems, CMS. From custom CMS solutions to popular platforms like October CMS or Statamic built on Laravel, it's a strong choice for managing content. RESTful APIs. With built-in tools like Laravel Sanctum and Passport, Laravel is an excellent choice for building backend APIs for mobile applications or single-page applications. SPAs, developed with frameworks like React, Vue, or Angular. SaaS applications. Software as a service products benefit from Laravel's scalability and features like queues for background processing and broadcasting for real-time updates. Well-known companies and organizations employing Laravel in their stack include BBC, Pfizer, and countless others. Its popularity is evident in developer surveys and job market demand. Setting expectations for this book. Throughout this book, our goal is to guide you from foundational concepts to building functional, modern web applications with Laravel. We will demystify the core components, provide practical examples, described conceptually to be audiobook-friendly, focusing on logic rather than direct code syntax, and equip you with the knowledge to confidently embark on your Laravel development journey. We'll start with setting up your development environment, then move through the core architecture, interacting with databases, handling user input, securing your application, and finally, getting your masterpiece live. By the end, you'll not only understand how to use Laravel, but also why its design choices lead to efficient, maintainable, and enjoyable web development. Let's begin. Setting up your Laravel workshop. Before you can start crafting modern web applications with Laravel, you need to set up your development environment, your Laravel workshop. This involves ensuring you have the necessary tools installed and configured on your computer. Think of it like a carpenter gathering their saw, hammer, and workbench before starting a project. The beauty of Laravel is its flexibility. There are several ways to set up your environment, catering to different operating systems and preferences. We'll cover the essential prerequisites and then explore some popular options for getting your local server running. Prerequisites, the essential tools. Laravel, being a PHP framework, naturally relies on PHP. Additionally, it leverages a few other key technologies. PHP. Laravel requires a recent version of PHP. At the time of this writing, Laravel 10 requires PHP 8.1 or higher. Always check the official Laravel documentation for the latest specific version requirements. PHP is the language your application will be written in and executed by. You'll need not just PHP itself, but also several PHP extensions, like PDO for database connections, MBString for multi-byte string handling, curl for making HTTP requests, JSON for data encoding, Filanfo for file uploads, and DOM for XML HTML file manipulation for Laravel to function correctly. Most modern PHP installations or development stacks come with these pre-enabled. Composer. This is the dependency manager for PHP. If PHP is the engine, Composer is the mechanic that ensures all the right parts are there and work together. When you start a new Laravel project or add new features, Composer fetches all the necessary libraries and packages that Laravel relies on. It's absolutely indispensable for modern PHP development. A database system. Almost all web applications need to store data persistently. Laravel works seamlessly with popular database systems. The most common choices include MySQL, a very popular open-source relational database, PostgreSQL, another powerful open-source relational database, often favored for larger applications. SQLite, a file-based database, excellent for small projects, development, or testing where a full-blown server isn't needed. For most local development, MySQL is a common and easy choice. Node.js and npm/yarn optional, but recommended for front-end assets. While Laravel handles back-end logic, modern web applications often include dynamic front-end components, styling, and JavaScript. Node.js is a JavaScript runtime, and npm Node Package Manager or Yarn are package managers for JavaScript libraries. Laravel frequently uses Node.js and npm to compile front-end assets, like CSS and JavaScript, using a tool called Laravel Mix or Vite, which we'll briefly touch upon later. You can build a functioning Laravel application without these, but for a truly modern application, they are highly recommended. Choosing your development environment, where to build. Setting up PHP, a web server like Apache or Nginx, and a database individually can be a bit tedious, especially for newcomers. Fortunately, there are several streamlined options for creating a local development environment, ranging from all-in-one packages to more specialized tools and even containerization. Here are the most popular choices. All-in-one software stacks, WAMP, MAMP, Laravel, XAMPP. These packages bundle an Apache or Nginx web server, MySQL database, and PHP, hence the acronyms. Windows Apache MySQL PHP, Mac OS Apache MySQL PHP, etc. They are often the easiest way to get started, especially on Windows or Mac OS. WAMP for Windows, MAMP for Mac OS Windows, XAMPP cross-platform. These provide integrated graphical interfaces for managing services manually. Laravel for Windows, recommended for Windows users. Often lauded as the best all-in-one solution for Windows. It's lightweight, fast, and pre-configured for many development tasks, offering very easy setup for Nginx, MySQL, PHP, Node.js, and even setting up pretty URLs, virtual hosts automatically. Laravel-specific tools, Valet, Homestead, Sail. These options are designed specifically with Laravel in mind, offering a more tailored and often more powerful development experience. Laravel Valet for Mac OS Linux, recommended for Mac OS users. A minimalist, super-fast Mac OS and Linux via a community-maintained version called Valet Linux development environment. It uses Nginx and a local DNS server to serve your Laravel applications. Valet is incredibly convenient for developers working on multiple Laravel projects simultaneously because you just cd into a project directory and it's instantly available in your browser. Laravel Homestead, cross-platform via Vagrant, a pre-packaged Vagrant box, a virtual machine that provides a complete, isolated development environment. Homestead is ideal if you want a consistent environment across different machines, as it runs a full virtual server configuration that mirrors a production environment. Laravel Sail, cross-platform via Docker, recommended for new Laravel projects. Sail is Laravel's official Docker development environment. Docker is a containerization technology that packages an application and all its dependencies into an isolated container. Sail runs your Laravel application, PHP, MySQL, Redis, and Mailpit for email testing within Docker containers. It comes pre-packaged with new Laravel installations and is quickly becoming the preferred choice for many developers due to its ease of setup, consistency, ensuring your development environment matches production, and alignment with modern deployment practices. For the purpose of this book, we'll assume a local setup where you can naturally execute common command line PHP and Composer commands. Laravel Sail is an excellent choice for a new project, as it's built in starting from Laravel 8. Installing Composer, the PHP package manager. Regardless of your chosen development environment, Composer is a non-negotiable tool. You'll install it by following the detailed instructions on the official Composer website, getcomposer.org, for your operating system. After installation, typing Composer version in your terminal should confirm it's working by displaying the installed Composer version. Creating your first Laravel project. Once PHP, your chosen local server, and Composer are ready, creating a new Laravel project is straightforward. Open your terminal or command prompt and navigate to the directory where you want to store your project. Then, run a Composer command like the following. Composer create project Laravel/Laravel my first app, preferredest. This instructs Composer to download the latest stable version of Laravel and all its dependencies into a new directory named my first app. The preferredest flag ensures that Composer pulls pre-packaged archives, which is generally faster. After the project is created, navigate into your new project directory. cd my first app, setting up and running with Laravel Sail, if you choose this path. If you opted for Laravel Sail, which is often pre-configured in new Laravel projects, you'll generally interact through its commands. To start the Docker containers for your application, from inside your project directory, you'll run vendor bin sailup. This command will build, if necessary, and start all the services your application needs, such as the PHP server, database, and, by default, a local mail server for testing. You can run it in the foreground or add D to run it in the background. Basic file structure tour, understanding your new application. Now that your project is created, let's take a quick walk through its main directories. Don't worry about understanding everything immediately. This is just a quick orientation. As we progress through the book, we'll dive deeper into each of these areas. App. This directory holds the core of your application's source code, including crucial parts like models for interacting with your database, controllers for handling requests, and various service providers. Bootstrap / contains files that handle the initial loading and bootstrapping of the framework. Config stores all your application's configuration files, which control various aspects of Laravel's behavior. Database / this is where you'll define your database structure using migrations, populate it with test data using seeders, and define factory blueprints for creating fake model instances. /. This is the web server's document root. Only files within this directory are publicly accessible via the web. It contains your main index.php file, which is the entry point for all web requests, along with compiled front-end assets. Resources contains your uncompiled front-end assets, like CSS and JavaScript source files that need to be processed, and your Blade template files, the HTML views for your application. Root/. This directory defines all the URL routes for your application, mapping incoming requests to specific actions within your code. Storage/. Used for various files generated by Laravel, such as compiled Blade templates, session files, cache data, and user-uploaded files. Tests, where your automated tests, both unit and feature tests, will reside, ensuring the quality and correctness of your application's logic. Vendor contains all third-party dependencies managed by Composer. You generally won't modify files in this directory. Env. This file stores environment-specific configuration variables, such as your database credentials, API keys, and other settings that change between development, staging, and production environments. It should always be kept out of version control for security. Composer.json. This file defines your project's Composer dependencies, the libraries your application needs, and other metadata for Composer. Running the development server. After your project is created and its dependencies installed, you can start a local development server to see your application in action. If you are using Laravel Sail, as started with vendor bin sail up. Once the containers are running, access your application by navigating your web browser to HTTP localhost. If you are not using Sail, perhaps using Laravel, WAMP, MAMP, or a manually configured environment. First, ensure your chosen local server software, e.g., Apache or Nginx via Laravel, WAMP, or MAMP, and database are running. Then, navigate to your project directory in the terminal and run the following artisan command: php artisan serve. This will typically start a built-in PHP development server, and your application will be accessible in your web browser at http 127.0.0.1:8000, or sometimes a slightly different port. Congratulations! If you see the beautiful Laravel welcome page in your browser, your Laravel workshop is set up and your first application is running. You've laid the essential groundwork. In the next chapter, we'll dive into the fundamental architecture of a Laravel application, understanding how a web request moves through its core components. The Laravel core. Understanding the request lifecycle and MVC. Now that your Laravel workshop is set up and your first project is running, it's time to peel back the curtain and understand how Laravel works internally. Every time you type a URL into your browser and hit enter, a complex yet highly organized process unfolds within your Laravel application. This process is known as the request lifecycle. Understanding it, along with the foundational Model View Controller, MVC, architectural pattern, is crucial for truly mastering Laravel development. How a web request flows through a Laravel application. The request lifecycle. Imagine a web request as a guest arriving at a meticulously organized party. The guest, your browser's request, doesn't just wander in. They follow a series of steps and introductions curated by the host, Laravel. The front controller, public/index.php, the grand entrance. Every single HTTP request to your Laravel application starts and ends at one file, public/index.php. This file is known as the front controller. Your web server, Apache, Nginx, or Laravel's built-in PHP artisan serve, is configured to direct all incoming requests to this file. The primary job of index.php is lean, but vital. It loads the Composer autoloader, which manages all the necessary libraries, initializes the core Laravel application instance, and then efficiently hands off the incoming HTTP request to the application's HTTP kernel. The HTTP kernel and service providers, setting the stage. Once the index.php file passes the request to the HTTP kernel, represented by app/http/kernel.php, the real magic of setting up the environment begins. The HTTP kernel is like the party planner. It's responsible for managing the application's global middleware and for systematically booting up almost all of the application's essential services through service providers. Service providers, bootstrapping essential services. Service providers are one of the most fundamental and powerful concepts in Laravel. They are the central place for configuring and bootstrapping all of your application services. Think of them as individual stations at the party, each responsible for setting up a specific system. One handles database connections, another takes care of routing, another prepares views, and so on. They register and boot their capabilities into Laravel's service container, making them available for use throughout the application. Middleware, the gatekeepers and enhancers. Before a request even reaches your application's specific logic, it passes through a series of middleware. Middleware are like security checks, bouncers at the door, or decorators. They are small, self-contained pieces of code that can inspect, modify, or even reject incoming requests entirely. They can also perform actions after the request has been processed. Common uses for middleware include ensuring a user is authenticated, protecting against cross-site request forgery, CSRF, attacks, logging requests, or rate-limiting access to certain parts of your application. Middleware forms a stack, processing the request sequentially before it reaches its final destination, and then potentially processing the response in reverse order as it exits. Routing and dispatching. Finding the right path. Once the request has successfully passed through any initial middleware, the router takes over. The router's job is to intelligently compare the incoming URL and its HTTP method, such as GET for retrieving information, POST for submitting data, against the routes you have defined in your routes directory. For example, Web PHP for typical web requests, or API PHP for API endpoints. If a match is found, the router dispatches the request to its designated handler, which is typically a method within a controller specifically designed to handle that particular request, or sometimes a simple anonymous function. Application logic controller closure, doing the work. This is where your specific application code executes. Inside your controller method, you will process any incoming request data, interact with your models, for instance, fetching data from the database, saving new records, or updating existing ones, perform any necessary business calculations or logical operations, and prepare data to be displayed. You will then determine the appropriate response, typically returning a formatted HTML view, issuing a redirect to another URL, or providing a structured API response, often in JSON format. Response. Sending it back. After your application logic has completed its work and generated an outcome, a response is prepared. This could be a fully rendered HTML page, a command to redirect the user's browser to a different URL, or structured JSON data intended for a client-side application. This response then travels back through the middleware stack in reverse order, allowing any configured middleware to modify the outgoing response if needed, and is finally sent back to the user's browser via the public/index.php file, completing the lifecycle. The Model View Controller, MVC, pattern explained in Laravel's context. The request lifecycle describes how a request travels through Laravel from beginning to end. The Model View Controller, MVC, architectural pattern, on the other hand, describes how you should organize your application's code to make it maintainable, scalable, and easy for multiple developers to work on. Laravel is deeply rooted in the MVC pattern, strongly encouraging this separation of concerns to keep your application modular and clean. Imagine building a house. The model is like the blueprints, the structural components, and the raw materials. It represents your house's data, e.g., its dimensions, materials used, number of rooms, and the fundamental rules for building and interacting with it. The view is the interior decoration, the paint colors, the furniture, and the landscaping. It's how the house looks and feels to visitors. It presents the finished structure and its details to the user. The controller is the architect or the contractor. They receive requests from the client, e.g., I want to see a house with 3 bedrooms. Consult the blueprints, models, to understand what's possible and what data is available, coordinate the building or presentation process, and eventually present the finished house, view, to the client. Let's break down each component within the specifics of a Laravel application. Model app/models/PHP, your data and business logic. Purpose: models are primarily responsible for interacting with your database. They represent the data structure of your application. For example, a user model might represent rows in a users table or a post model for records in a posts table. In Laravel, Laravel uses Eloquent ORM, Object Relational Mapper, for its models. Each Eloquent model typically corresponds to a specific table in your database. The beauty of Eloquent is that instead of writing raw SQL commands, you interact with your database tables intuitively as if they were simple PHP objects. What they do: models handle retrieving data from the database, saving new data, updating existing records, defining how different pieces of data relate to each other, e.g., a user has many posts, a post belongs to a user, and encapsulating business logic directly related to that specific type of data. View resources/views/blade PHP, presenting information. Purpose: views are solely responsible for presenting the data to the user. They are the user interface part of your application. Their job is to display information in a readable and understandable format. In Laravel, Laravel uses the Blade templating engine for its views. Blade files are essentially plain HTML files with special Blade directives, which are typically prefixed with an @ symbol that allow you to embed dynamic data, create loops, define conditional elements, and inherit layouts from other templates. What they do: views take the data provided by the controller and render it into a human-readable format, which is almost always HTML for web applications. Views should contain minimal procedural logic. Their primary responsibility is to display what they are given. Controller app/http/controllers/php, the traffic cop and coordinator. Purpose: controllers act as the intermediary between the model and the view. They are the primary handlers for incoming requests. They receive requests from the client's browser, process them, interact with models to get or manipulate data as needed, and then pass that data to the appropriate view for display or craft an API response. In Laravel, controllers are PHP classes with methods that are designed to handle specific HTTP actions. For instance, an index method might list all resources, a show method might display a single resource, a store method might save new data, an update method might modify existing data, and a destroy method might delete data. What they do: controllers handle the incoming HTTP requests, call relevant methods on the models to interact with the database, perform any necessary input validation or authorization checks, determine which view to load, pass the prepared data to that view, and finally return the complete response back to the user. Dependency injection and the service container, Laravel's clever helpers. While the MVC pattern dictates how your application's logic is structured, two underlying concepts, the service container and dependency injection, are crucial to Laravel's elegance, flexibility, and testability. Service container, also known as the IOC container. Think of the service container as a sophisticated filing cabinet or a specialized vending machine for all the different objects and services your application might need. Instead of you manually creating every object or figuring out how to construct its dependencies, you simply ask the service container for what you need. It then intelligently resolves, creates, and configures that object, automatically injecting any other services or objects it depends on. This central registry makes it easy to manage complex class dependencies. Dependency injection, DI. This is a software design pattern where classes receive their dependencies from the outside, rather than creating them internally. For example, if your controller method needs access to the current HTTP request, you don't manually create a request object within the method. Instead, you simply declare that dependency by type hinting the illuminate /HTTP/request class in the method's parameter list. Laravel's service container automatically injects the current request object into your method when it's called. This pattern has enormous benefits, including making your code much easier to test, more flexible for future changes, and more maintainable. Understanding the request lifecycle helps you trace how data flows through your application, diagnose problems, and optimize performance. A solid grasp of MVC provides a structural blueprint for organizing your code. Finally, appreciating the role of the service container and dependency injection will empower you to write more organized, testable, and maintainable Laravel applications, taking full advantage of the framework's design philosophy. In the next chapter, we'll put these concepts into practice by defining routes, building controllers, and creating views to bring your application to life. Navigating your application, routing, controllers, and views. With your Laravel environment prepared and a foundational understanding of the request lifecycle, it's time to delve into the practical artistry of building interactive web applications. This chapter will connect the theoretical dots of MVC by showing you how to define the paths users take through your application via routing, how to process their requests and orchestrate interactions using controllers, and how to present engaging information back to them through views. Routing, defining the paths in your application. In any web application, users access different parts of your site by typing URLs into their browser. Laravel's routing system acts as the central map, intelligently directing incoming requests to the correct part of your application's code. It's powerful, flexible, and surprisingly intuitive, allowing you to define clean, memorable URLs. Laravel's routes are primarily defined in files located within the routes directory, routes/webphp. This file is for your typical web user interface routes. These routes are automatically assigned the web middleware group, which includes features like session management and crucial CSRF, cross-site request forgery protection, making them suitable for browser-based interactions. Routes/API PHP. This file is dedicated to routes used for building RESTful APIs. These routes are assigned the API middleware group, which provides features like rate limiting and are designed to be stateless, meaning they don't rely on session cookies. Basic routing definition. A route maps an HTTP method, like GET for retrieving data, POST for submitting data, and a specific URL path to a piece of code that Laravel should execute when that URL is accessed. Displaying a simple message, you can define a route that directly returns a string or simple content. For instance, to show a welcome to Laravel message when a user visits welcome, you would instruct Laravel's routing system to handle a GET request to that path by returning the desired text. Route parameters, dynamic URLs. To display dynamic content based on information embedded directly within the URL, you use route parameters. For example, if you wanted to display details for a specific user, your URL might look like users 123, where 123 is the user's identification number. You would define a route pattern like /user/id, and Laravel would recognize id as a placeholder, automatically passing its value, e.g., 123, to your handling function or controller method. Named routes, referring to URLs by name. Instead of hard-coding URLs, which can break if you later change the URL path, Laravel allows you to assign unique names to your routes. For instance, if you have a route for your user dashboard at dashboard, you can name it user dashboard. Then, anywhere in your application, you can refer to it by its name. If the URL for user dashboard changes to my account dashboard, you only update the route definition, and all references to user dashboard within your application will automatically resolve to the new URL. This makes your links much more robust and easier to manage. Route groups, organizing and applying middleware. As your application grows, defining each route individually can become cumbersome. Route groups allow you to apply common attributes, such as middleware, like auth to ensure a user is logged in, or URL prefixes, like admin for all administration panel routes, to a collection of routes. This helps keep your route definitions clean, organized, and prevents repetition. For example, all routes under a group prefixed with admin and protected by the auth middleware would inherit those properties without needing to be defined for each individual route. Controllers, orchestrating the application logic. For anything beyond the most basic responses, like simply returning a string from a route, you'll want to use controllers. Controllers encapsulate the logic for a specific section or resource of your application, making your code organized, reusable, and adhering to the MVC pattern. Creating a controller. Laravel's Artisan command line tool makes this easy. You can generate a new controller, for example, post controller, with a simple Artisan command. This creates a new PHP class, typically within the app/http/controllers directory, linking a root to a controller method. Instead of defining the logic directly within the root definition using an anonymous function, you tell the root to dispatch the request to a specific method within your controller. So, a GET request to posts might be linked to the index method of your post controller. Inside a controller method is where the real work happens for a given request. It receives the HTTP request object, which gives it access to all incoming data, like form submissions, URL parameters, headers. Inside the method, you will perform necessary actions. This commonly involves interacting with your models to retrieve or store data in the database, processing input, performing any required business logic, and finally, preparing the response. The response usually takes the form of rendering a view with data, redirecting the user to another page, or returning structured data for an API. Views, Blade templating engine. Crafting the user interface. Once a controller has processed a request and potentially fetched data, it needs to present that data to the user in an understandable and visually appealing way. This is where views come in. Laravel's default templating engine is called Blade. What is Blade? Blade is a powerful yet simple templating engine provided by Laravel. It allows you to use plain PHP code within your view files, but provides convenient shortcuts or directives, always prefixed with an @ symbol, for common tasks. This makes your view code much cleaner, more readable, and separates presentation logic from your application's core logic. Creating a Blade view. View files are stored in the resources views directory and must end with the Blade PHP extension, e.g., resources/views/posts/indexBladePHP. Basic Blade syntax. Displaying data. To securely display a variable's content, you simply wrap it in double curly braces, like variable name $. Blade automatically escapes any HTML characters within the variable, protecting your application from cross-site scripting (XSS) attacks. Control structures. Blade provides intuitive directives for common PHP control structures. For example, @if condition, @else, @indif for conditional logic, @for each items as item, @end_for_each for looping through collections, and @for I equals 0, I5, I++, @end_for for simple loops. Comments. Blade comments. This is a Blade comment, are not included in the final HTML sent to the browser, making them useful for internal notes within your templates. Layout inheritance. Reusing page structure. One of Blade's most powerful features is its support for template inheritance. This allows you to define a master layout, e.g., in a file like resources/views/layouts/appBladePHP that contains the common structural elements of your web pages, such as the header, navigation, footer, and basic HTML boilerplate. You then use @yield section name directives within the master layout to define slots where child views can inject their specific content. Child views then use @extends layoutsap to inherit the layout and @section section name, @endSection to fill those slots. This dramatically reduces code duplication and ensures a consistent look and feel across your application. Passing data to views. Controllers are responsible for retrieving data, often from models, and then passing that data to the appropriate view for display. In Laravel, you typically pass data to a view as an associative array to the view helper function. For example, a controller might return a view with data like this. Return view posts.index, posts equals posts collection, page title equals all blog posts. In the Blade view posts/indexBladePHP, you can then access this data directly as regular PHP variables, e.g., page title to display the page title, and loop through posts to display individual post details. Building a simple Hello Laravel page. To bring all these concepts together, let's trace the steps for building a simple welcome page. Controller. First, you would create a greeting controller using Laravel's Artisan command line tool. Controller method. Within this greeting controller class, you would add a method, let's say hello, that prepares a name variable, perhaps hard-coded for now or dynamically retrieved later, and then returns a view, passing this name. The logic would instruct Laravel to return a view named hello and provide it with the name variable. Route definition. Next, in your routes/web PHP file, you would define a route. When a user sends a GET request to the URL hello, this route would tell Laravel to execute the hello method inside your greeting controller. View file. Finally, you would create a blade view file named hello_blade_php inside your resources views directory. This file would contain basic HTML, and within it, you would use blade syntax to display the past name variable, perhaps inside an h1 tag like h1 hello, name, h1. When you then visit hello in your browser, Laravel's routing system finds the match, dispatches the request to your controller's hello method, which then renders the hello blade view with the provided name, ultimately sending a personalized hello name message back to your browser. This fundamental flow forms the backbone of almost every interactive feature in a Laravel application. In the next chapter, we'll connect our application to the real world by diving into databases and Laravel's powerful Eloquent ORM, allowing your applications to store and retrieve persistent data. Connecting to data, Eloquent ORM and databases. Most web applications aren't truly useful unless they can store and retrieve information persistently. Whether it's user profiles, product listings, blog posts, or order details, data is the lifeblood of almost every dynamic application. This chapter will guide you through connecting your Laravel application to a database, and more importantly, introduce you to Laravel's crown jewel for database interaction, the Eloquent ORM. Introduction to databases and SQL briefly. At its core, a database is an organized collection of data. For most web applications, we deal with relational databases like MySQL, PostgreSQL, or SQLite. These databases organize data into structured tables, where each table has columns defining attributes like a user's name or email, and rows representing individual records. Data is related between tables using keys. For example, a posts table might have a userid column that links each post back to a specific user in the users table. Traditionally, interacting with these databases involves writing queries in a specialized language called SQL, Structured Query Language. SQL statements allow you to select, retrieve, insert, add, update, modify, and delete, remove data. While powerful, writing raw SQL can be tedious and prone to errors, especially as your application grows. This is where Laravel's Eloquent ORM steps in to simplify and abstract away much of that complexity. Laravel's approach to databases, configuration, and environment variables. Before your Laravel application can communicate with a database, it needs to know how to connect. This connection information is primarily managed through two places. Env-file. This file, located at the root of your project, stores environment-specific configuration variables. For database connections, you'll find entries like dbconNCTION, e.g., MySQL, PGSQL, SQLite, DBHOST, DBPORT, DBDATABASE, DBUSERNAME, and DBPASSWRD. It's crucial that this file is not committed to version control, as it often contains sensitive credentials. Each deployment environment, development, staging, production, will have its own env file. Config/database.php. This configuration file contains the detailed setup for all your database connections. It references the values from your env file to establish the actual connection parameters. You rarely modify this file directly unless you're adding entirely new database connections or customizing driver options. Before you start, you'll need to ensure that the actual database itself exists on your local server or hosting environment, and that the credentials in your env file match those of your created database. Migrations, building your database schema with version control. In traditional development, you might manually create or modify database tables. However, this quickly becomes unmanageable in team environments or when deploying to multiple servers. Laravel's migrations provide a powerful, programmatic way to manage your database schema, acting as version control for your database. What are migrations? Think of a migration as a blueprint for a specific change to your database. Each migration represents a step in your database's evolution, allowing you to define new tables, add columns, modify existing ones, or remove them, all through PHP code. Creating a migration. You use an artisan command from your terminal. For example, PHP artisan make migration, create a product stable. This generates a new PHP file within your database migrations directory. The file name often includes a timestamp, ensuring that migrations are run in the correct order. Defining schema. Each migration file contains two key methods. The up method defines the changes to be applied when the migration is run, e.g., creating a new products table with columns for id, name, price, and timestamps, which automatically manage created at and updated at. The down method defines how to reverse those changes, e.g., dropping the products table. This is essential for rolling back undesirable updates. Running migrations. To apply all pending migrations and update your database schema to the latest version, you execute PHP artisan migrate. Rolling back migrations. If you need to undo the last batch of migrations, e.g., after realizing a mistake, you can use PHP artisan migrate, rollback. For a complete reset, PHP artisan migrate, fresh, seed is commonly used in development. It drops all tables, reruns all migrations from scratch, and then executes any configured database seeders. Migrations ensure that your database structure is consistently managed across all environments and developers, making collaborative development much smoother. Eloquent ORM. Interacting with your database through objects. Eloquent is arguably Laravel's most beloved and powerful feature for database interaction. It's an object relational mapper, ORM, which means it provides an elegant way to interact with your database tables by treating them as if they were simple PHP objects. Each model in your application typically corresponds to a table in your database. Defining models. You create a new model using artisan, PHP artisan make, model product. This generates app/models/product PHP. By convention, an Eloquent model named product will automatically assume it corresponds to a database table named products, pluralized form. Within the model, you can define properties like fillable to specify which attributes can be mass assigned for security, or hidden to prevent certain attributes like passwords from being exposed in arrays or JSON output. Basic CRUD operations, create, read, update, delete. Eloquent allows you to perform common database operations using expressive, readable PHP syntax rather than raw SQL. Create. To add a new record, you might instantiate a new model and save it, or use the create method with an array of data. For example, conceptually, product.create with an array containing name as laptop and price as 1200.0. This abstracts the SQL insert statement. Read. To retrieve data, Eloquent offers numerous options. Product.all retrieves all records. Product.find with ID1 gets a single record by its primary key. And product.where price is less than 500 then get retrieves records matching specific conditions. Each returned record is an instance of your Eloquent model, making its attributes directly accessible as properties. Update. To modify an existing record, you first retrieve the model instance, then change its properties, and finally call the save method on that instance. Alternatively, you can update multiple records that match specific criteria. For example, find the product with ID1, set its price to 1100.0, and save it. Delete. To remove a record, you retrieve the model instance and call delete on it. You can also delete multiple records based on conditions. For example, find the product with ID1 and delete it. Relationships. Connecting your models. True power of Eloquent comes from managing relationships between your models. Eloquent supports various types of relationships, including one-to-one, e.g., a user has one profile; one-to-many, e.g., a user has many posts or a category has many products; many-to-many, e.g., a user can have many roles, and a role can be assigned to many users. By defining these relationships within your models, Eloquent allows you to easily navigate between related data without writing complex joins. For instance, after fetching a user model, you can access their related posts almost as if posts were a simple property of the user object. This significantly simplifies data retrieval and manipulation. Database seeding. populating your database with dummy data. During development and testing, you often need realistic data in your database to work with. Database seeders allow you to programmatically populate your database with dummy data, ensuring consistency and ease of setup across development environments. Creating a seeder. Similar to migrations, you generate a seeder using Artisan, PHP Artisan Make Seeder Product Seeder. This creates a file in database seeders defining seed data. In the seeders run method, you use Eloquent to create records. You can either directly create model instances or, more commonly, use Laravel's factories to generate large amounts of realistic, fake data. For example, you might instruct the seeder to create 50 product instances with random but sensible names and prices. Running seeders. You can run specific seeders using PHP Artisan DB, seed class equals product seeder, or run all default seeders by simply executing PHP Artisan DB, seed. As mentioned earlier, PHP Artisan migrate. Fresh, seed is a convenient command that clears your database, runs all migrations, and then runs all seeders, which is immensely useful for quick development resets. Connecting to a database, structuring your schema with migrations, interacting with data via Eloquent models, and populating your database with seeders are foundational skills for almost any dynamic web application. With these tools, you can now confidently store, manage, and retrieve the information that powers your Laravel projects. In the next chapter, we'll build upon this by focusing on handling user input through HTML forms and ensuring data integrity with Laravel's powerful validation system. Handling user input, forms, and validation. Interactive web applications allow users to do more than just view content. They let users provide information, register accounts, submit comments, update their profiles, and much more. This vital user input typically comes through HTML forms, which serve as the primary interface for collecting data from your application's users. However, accepting user input directly without scrutiny is like opening your front door to strangers without checking their ID. It's a huge security and data integrity risk. This chapter will guide you through the process of creating HTML forms, retrieving the data users submit, and, most importantly, rigorously validating that data to ensure it meets your application's requirements, maintains data integrity in your database, and remains secure from malicious input. HTML forms, the gateway for user input. An HTML form is a container for various input elements, text fields, checkboxes, radio buttons, dropdowns, etc. When a user completes the form and clicks a submit button, the data from these input elements is sent to your server. Key attributes for an HTML form are action. This attribute specifies the URL to which the form data should be sent when the form is submitted. In Laravel, this will typically be one of your routes. Method. This attribute defines the HTTP method used to send the data. For actions that retrieve data, like a search form, you might use GET. However, for actions that change data on the server, like creating a new record, updating existing data, or deleting something, you should always use POST or PUT patch delete methods, which we will discuss briefly when covering RESTful APIs, but are sent as POST internally by HTML forms, requiring a special field in Laravel. A conceptual form for adding a product might include a text input for the name, a text area for the description, and a number input for the price, along with a submit button. CSRF protection, a crucial security measure. Before diving into processing form data, we must address a critical security concern: cross-site request forgery, CSRF, attacks. A CSRF attack tricks an authenticated user into performing an unintended action on a web application where they are currently logged in. Laravel includes robust, built-in protection against CSRF attacks. That's CSRF Blade Directive, which you should include within every HTML form that uses the POST method, or PUT patch delete via a hidden field, is vital for security. When Laravel renders your form, this directive automatically inserts a hidden input field into your HTML. Input type equals, hidden name equals, token, value equals, r40m_ring. This token is a unique, randomly generated token for the user's current session. When the form is submitted, Laravel automatically verifies this token against the one stored in the user's session. If they don't match, the request is rejected. This mechanism ensures that only legitimate requests originating from your application can make changes to your data, significantly enhancing security. Always include @CSRF in your forms used with webroutes. Retrieving request data in controllers. When a user submits a form, the data is sent to the URL defined in the form's action attribute, and your Laravel application's router directs it to the appropriate controller method. Inside that method, you can easily access the submitted data. The most common way to access incoming request data is by type hinting illuminate /http/request in your controller method signature. Laravel's service container will automatically inject the current HTTP request object into your method. Once you have the request object, you can retrieve input in several ways. Get all input. You can retrieve all submitted input fields as an associative array using formData=requestAll. Get a specific field. Access individual fields by their name using productName=requestInput name. For simple fields, you can often use dynamic properties like requestName. Get only specific fields. If you only need a subset of the fields and want to ignore others, you can use safeData=requestOnly, name, description, price. There's also except, to get all fields except specified ones. Validation, ensuring data integrity and security. Retrieving data is only half the story. The next, crucial step is validation. Validation is the process of checking if user-provided data meets your application's predefined rules and constraints. This ensures data integrity, e.g., a price is a number and positive, security, e.g., preventing malicious scripts, and a consistent user experience, e.g., ensuring all required fields are filled. The simplicity of the validate method. Laravel's validate method on the request instance is the easiest and most common way to perform validation. When you call validate, with an array of rules, Laravel handles everything. Conceptual validation, in a controller method. Validated data is only populated if validation passes. Validated data equals request validate. Name equals required string max, 255. Description equals nullable string. Nullable means optional, but must be string if present. Price equals required numeric min, 0.01. Email equals required email unique. User's email must be unique in user's table in email column. Password equals required confirmed min 8. Confirmed checks for password confirmation, field. Image equals nullable image max 2048. Optional image max 2 MB. If validation passes, the code continues from here. Importantly, validated data will only contain the fields that were defined in the validation rules, filtered and cleaned according to the rules. Understanding validation rules. Validation rules are specified as strings or arrays. You can chain multiple rules using the pipe symbol. Laravel provides a vast array of built-in rules. Some common ones include required. The field must be present and not empty. String, the field must be a string. Numeric, the field must be a number. Min value, max value, minimum maximum length for strings, minimum maximum value for numbers. Email, the field must be a valid email format. Unique a table, column, ensures the value is unique in a specified database table and column. Confirmed, often used for password confirmations, ensuring a field e.g., password matches a corresponding confirmation field e.g., password confirmation. Image MIMES, JPEG PNG, max, size for file uploads. Automatic redirects and error messages. A key feature of Laravel's validate method is its behavior on failure. If validation fails for any reason, Laravel automatically redirects the user back to the previous page, typically the form they just submitted. Flashes the validation errors to the session, making them available in the view. Flashes the old input data, the data the user originally typed, back to the session, so you can repopulate the form fields. This prevents users from having to re-enter everything if there was a mistake. Displaying validation errors to the user. Laravel makes it very easy to display these errors in your blade views. The errors variable is automatically available in all your views. You can check if there are any errors using @if errors any. to display a general error message or a list of all errors. For specific error messages next to their corresponding input fields, you can use the @errorblade directive. For example, input type equals text, name equals email value equals old email, @error email, div, message, div @enderer. The old email helper is used to repopulate the input field with the user's previous input, making the user experience much smoother. Form requests, organizing complex validation logic. For more complex forms, or when you want to keep validation logical entirely separate from your controllers, Laravel offers form requests. These are special classes designed to centralize both validation rules and authorization logic. Creating a form request, you generate a form request using Artisan, PHP Artisan make, request store product request. This creates a new PHP class typically located in app/http/request/store product request PHP. Defining rules and authorization. A form request class contains two main methods. The rules method. Here, you define all the validation rules for the incoming request, mirroring the array you'd pass to the validate method. The authorize method. This method determines if the currently authenticated user is allowed to make this request. It returns true or false. For example, only an administrator might be allowed to store a new product. Using a form request in a controller. To use a form request, you simply type in your custom form request class in your controller method's signature instead of the generic illuminate /http/request. For example, public function store product request. When Laravel sees this, it automatically runs the authorize method first. If it returns false, an unauthorized response is returned immediately. If authorize returns true, Laravel then runs the rules method. If validation fails, it behaves like the validate method, redirecting back with errors. If both pass, the controller method is executed, and you can get the already validated and filtered data using request validated. Handling user input safely and efficiently is a hallmark of a robust web application. By employing Laravel's expressive HTML forms, its powerful and flexible validation system, and understanding the vital role of CSRF protection, you can confidently accept and process information from your users. This lays the groundwork for secure, reliable, and user-friendly application features. Next, we'll build on user management by diving deeper into authentication and authorization, allowing you to manage who can access and do what within your application. Securing your application, authentication and authorization. Building an application that handles user-specific data or features necessitates robust security. There are two fundamental questions that any secure application must answer for every user interaction. Authentication: who are you? This is the process of verifying a user's identity, typically through credentials like a username and password. Authorization: what are you allowed to do? Once a user's identity is confirmed, authorization determines what resources they can access and what actions they are permitted to perform within the application. Laravel provides incredibly powerful, flexible, and opinionated systems for both authentication and authorization, simplifying what used to be a complex, time-consuming, and often error-prone aspect of web development. Authentication: who are you? Laravel's authentication system is designed to be highly customizable while providing sensible defaults. It makes implementing common features like user registration, login, password resets, and email verification remarkably straightforward. The auth facade and guarded system. At the core of Laravel's authentication is the auth facade, which provides a convenient way to interact with the authenticated user. Behind the scenes, Laravel uses guards to define how users are authenticated and stored. The default WebGuard uses session storage and cookies, making it ideal for typical browser-based applications. Other guards can be configured for API token authentication or other custom mechanisms. For example, you can check if a user is logged in using auth, check, retrieve the currently authenticated user object with auth, user, or log a user out using auth, logout. Authentication scaffolding, Breeze and Jetstream. For developers who want to get started quickly with robust authentication features already in place, Laravel offers official starter kits. Laravel Breeze. This is a minimalist yet full-featured implementation. It provides all the essential scaffolding for user registration, login, password reset functionality, email verification, and password confirmation. When you install Breeze via Composer and run an artisan command, it generates all the necessary routes, controllers, views, using Blade, and database migrations, giving you a functional authentication system out of the box. It's an excellent choice for new projects or those requiring a simple, traditional authentication flow. Laravel Jetstream. For more advanced applications, Jetstream builds upon Laravel Fortify, a backend authentication service, and offers a richer set of features. Beyond basic authentication, Jetstream includes two-factor authentication, API token management, and even team management functionality, allowing users to create and belong to multiple teams. Jetstream integrates with modern front-end stacks like Livewire, Laravel's default for Jetstream, or Inertia.js for single-page application patterns. Both Breeze and Jetstream significantly accelerate development by providing a secure, tested, and maintainable authentication foundation without you having to write every component from scratch. Manual authentication, conceptual understanding. While scaffolding is common, it's useful to understand the underlying mechanics. At its core, manual authentication involves retrieving user-provided credentials, e.g., from a login form, attempting to log the user in using methods provided by the auth facade, which internally verifies the password, checking the login status, and providing a mechanism for logging out. Password hashing and security best practices. Never store plain text passwords in your database. This is a non-negotiable security principle. Laravel automatically enforces this by using strong, one-way hashing algorithms like bcrypt or Argon2, configured via config/hashing PHP. When a user registers or changes their password, Laravel's authentication system, or the hash, make, helper if you're doing it manually, will hash the password before storing it. During login, the provided password is hashed and compared against the stored hash. This means even if your database is compromised, attackers cannot retrieve the original passwords. Authorization. What are you allowed to do? Once a user is successfully authenticated, the next step is determining what actions they are authorized to perform and what resources they are allowed to access. Laravel offers two primary mechanisms for structuring authorization logic: gates and policies. Gates, simple, closure-based authorization. Gates are a simple yet powerful way to define authorization rules. They are essentially PHP closures, anonymous functions, that return true or false based on whether a given action is authorized for the currently authenticated user. Gates are typically defined in your application's auth service provider. They are suitable for simple, global checks not directly tied to a specific Eloquent model. Conceptual example. You might define a gate named viewAdminPanel. This gate's logic would check if the authenticated user has an admin role. Checking gates. You can check a gate programmatically using gate, allows, viewAdminPanel. In your Blade views, you can use the @can directive, @can viewAdminPanel, @endCan to conditionally display parts of the UI. Conversely, @cannot can be used to hide elements. Policies, model-based authorization. Policies are classes that organize authorization logic for a specific Eloquent model, e.g., a post model, a product model, or a user model. They are ideal when you have multiple authorization actions related to a single resource, such as view, create, update, or delete actions on a post. Policies keep your authorization rules structured and maintainable. Creating a policy. You generate a policy using an artisan command. PHP artisan make a policy post policy model equals post. This creates a post policy class in app policies defining authorization logic. Inside a policy class, each method typically corresponds to a specific action. For example, an update method might receive the authenticated user and the specific post instance being updated. The method would return true if the user is authorized to update that post, e.g., if they are the author or an administrator, and false otherwise. Using policies. Policies are registered in your auth service provider. In your controllers, you can easily check policies using this authorize, update, post, or type hint the policy in a form request. If the user is not authorized, Laravel will automatically throw an access denied HTTP exception. In blade views, you use @can, update, post. @end can, passing both the action name and the model instance to be checked. Middleware for authentication and authorization. Middleware, as discussed in Chapter 3, is a powerful tool for centrally applying checks to groups of routes. Laravel's authentication and authorization systems frequently leverage middleware to enforce security rules before a request even reaches your controller. Auth middleware. This middleware, e.g. route, middleware, auth group, ensures that a user is successfully logged in before they can access a specified route or group of routes. If a guest tries to access a protected route, they are automatically redirected to the login page. Can middleware, this middleware can update product, allows you to quickly assert authorization based on a gate or policy right within your route definitions. It takes the action name and, optionally, a route parameter that resolves to a model instance. For example, if a user attempts to access a route that edits a product, the can middleware could ensure that the user has the update permission on that specific product. Laravel's comprehensive authentication and authorization systems are game changers for building secure web applications. They empower you to manage user identities and permissions with less effort and greater confidence, allowing you to focus on your unique business logic while trusting Laravel to handle the essential security foundations. In the next chapter, we'll shift our focus to building APIs, a crucial skill for modern applications that need to communicate with mobile apps, single-page applications, or other services. Building APIs with Laravel. A RESTful approach. In today's interconnected digital landscape, web applications rarely operate in isolation. Mobile apps, sleek single-page applications, SPAs built with modern JavaScript frameworks, and integrations with third-party services often need to communicate with your application's backend data and business logic. This is where application programming interfaces, or APIs, come into play. Laravel is exceptionally well-suited for building powerful, elegant, and secure RESTful APIs. What are APIs and why use them? An API, Application Programming Interface, is a set of rules and definitions that dictate how different software applications can communicate with each other. In the context of web development, a web API allows distinct software systems, like a mobile app and your server, or one server talking to another, to exchange data and trigger actions over the internet. The primary reasons for building an API for your Laravel application include decoupling front-end from back-end. An API allows you to completely separate your user interface, which might be a React or Vue SPA or a native mobile app, from your server-side logic and database. This means front-end and back-end teams can work independently and evolve their parts of the system separately. Supporting multiple client types. A single API can serve data to a variety of clients: your public website, an internal administration dashboard, a mobile app, or even an IoT device. Facilitating third-party integrations. APIs enable other businesses or developers to build services that interact with your application, expanding your ecosystem without requiring direct access to your codebase. Introduction to RESTful principles. While the term API is broad, most web APIs today adhere to the RESTful, representational state transfer, architectural style. REST emphasizes a standardized, stateless approach to communication over HTTP. Resources. In a RESTful API, everything is treated as a resource, which is an abstract representation of data. Each resource has a unique identifier, typically a URL, e.g., products, users 123. Standard HTTP methods. REST leverages standard HTTP methods to perform actions on these resources. GET, used to retrieve a resource or a collection of resources. POST, used to create a new resource. Put patch, used to update an existing resource, put for full replacement, patch for partial modification. Delete, used to remove a resource. Statelessness, each request from a client to the server must contain all the information necessary to understand the request. The server should not store any client context between requests. This improves scalability and reliability. JSON, JavaScript Object Notation. While not a strict REST requirement, JSON has become the de facto standard for data exchange in modern RESTful APIs due to its lightweight nature and ease of parsing by various programming languages. API routes, defining your endpoints. Laravel provides a dedicated file for defining your API routes, routes/API PHP. Routes defined here are automatically prefixed with /API and are assigned the API middleware group. This group includes useful middleware such as rate limiting and ensures that session state cookies is not expected, aligning with RESTful stateless principles. Defining API routes is very similar to defining web routes, but instead of returning HTML views, they will eventually return JSON data. For example, to manage a collection of products, a GET request to /API/products would typically list all products. A POST request to /API/products would create a new product. A GET request to /API products 123 would show the details of the product with ID 123. A PUT or patch request to /API products 123 would update the product with ID 123. A delete request to /API products 123 would remove the product with ID 123. These routes would then point to methods within your application's controllers, specifically designed to handle API requests. Returning JSON responses. Unlike web controllers that typically return blade views, API controllers return structured data, almost always in JSON format. Laravel simplifies this immensely through the response helper function. When your controller method has processed an API request, e.g., fetched data from the database or saved new data, you can return that data as a JSON response. For instance, if you have a collection of product objects retrieved from your database, your controller method would instruct Laravel to return response.json with that product collection. Laravel's helper automatically handles the conversion of your PHP arrays or objects into JSON format and sets the appropriate content type header, typically applications/JSON, in the HTTP response. You can also specify HTTP status codes to indicate the outcome of the request. A status code of 200 OK usually means the request was successful and data is returned. 201 created is used when a new resource has been successfully generated by a POST request. 404 not found indicates that the requested resource does not exist. 204 no content is used for successful delete requests where no data needs to be returned. API resources, transforming models for API output. While you can return an Eloquent model or collection of models directly as JSON, this often isn't ideal for APIs. Your database schema might contain sensitive fields like password hash, unnecessary fields, or fields that need reformatting, like dates. Moreover, you might want to conditionally include related data. Laravel's API resources provide a powerful and convenient way to transform your Eloquent models into a format that is specifically tailored for your API's output. They act as a transformation layer between your database data and the JSON response your API sends. Creating a resource, you can generate a new resource class using an artisan command, for example, make resource product resource. This creates a class file, typically in the app/http/resources directory. Defining transformation logic. Inside the product resource PHP file, you define a toArray method. This method dictates the exact structure and content of the JSON that will be sent back for a single product. Here, you can selectively include only the necessary attributes, e.g., expose product name instead of name if desired. Format attributes, e.g., format a database timestamp into a human-readable date string. Conditionally include related resources, e.g., only include the product's categories if explicitly requested or if they have already been loaded from the database. Using resources in controllers. In your API controller, instead of directly returning raw Eloquent models, you wrap them in their respective resource classes. For a single product, you would return new product resource with the product object. For a collection of products, you would use product resource : collection with the collection of product objects. API resources ensure that your API's JSON contract remains consistent and exposes only what's necessary, regardless of underlying database changes. API authentication, stateless security. As RESTful APIs are stateless, they typically don't rely on traditional HTTP sessions and cookies for authentication, which are common for web applications. Instead, they use token-based authentication. Laravel provides two excellent solutions for this. Laravel Sanctum, recommended for SPAs and mobile APIs. Sanctum is Laravel's lightweight and flexible authentication system designed for single-page applications, SPAs. For SPAs hosted on the same domain as your API, Sanctum uses Laravel session cookies for authentication, but ensures that requests originate from your SPA to prevent CSRF attacks. This offers a seamless authentication experience for first-party SPAs, mobile applications, and other third-party APIs. For clients like mobile apps, iOS, Android, or external services, Sanctum enables token-based authentication. Users can generate long-lived API tokens. These tokens are then included with each API request, typically in the authorization. Bearer your token here, HTTP header. Your Laravel API then verifies the token with Sanctum to authenticate the request. Sanctum is the go-to solution for most first-party API scenarios due to its simplicity and effectiveness. Laravel Passport for robust OAuth 2 APIs. Passport provides a full OAuth 2 server implementation for your Laravel application. This is a more comprehensive solution ideal for scenarios where you need to allow third-party applications to access your users' data with granted permissions, similar to how Google or Facebook allow other apps to access your profile data with your consent. Passport offers various grant types suitable for different client types, e.g., authorization code grants for web applications, client credentials grants for machine-to-machine communication. To protect your API routes, you apply authentication middleware. For example, Auth, Sanctum, or Auth, API middleware would ensure that only authenticated requests with a valid token or session can access the specified endpoints. Building robust and secure APIs with Laravel is a cornerstone of modern application development. By understanding RESTful principles, leveraging Laravel's dedicated API routing, transforming data with API resources, and securing your endpoints with powerful tools like Sanctum or Passport, you are well equipped to build the backends for any client-side application. Next, we'll shift our focus to ensuring the quality and reliability of your entire Laravel application through effective testing strategies. Ensuring quality. Testing your Laravel application. In the world of software development, building features is only half the battle. Ensuring they work correctly and continue to work as you add more functionality is equally, if not more, important. This is where automated testing comes in. Testing provides a crucial safety net, allowing you to confidently refactor existing code, add new features, and deploy your application to production, knowing that existing functionality hasn't been inadvertently broken by your changes. Laravel provides robust, built-in testing features, making it a joy to write comprehensive tests. Why testing is crucial for robust applications. Imagine making a change to one part of your application and unknowingly breaking something completely unrelated in another part. Without automated tests, you'd only discover this defect potentially much later, perhaps after it has already impacted your users. Automated tests help prevent this by catching bugs early. Tests can identify issues immediately upon introducing a change, often before the code is even committed to version control. Preventing regressions. As your application evolves, new features can sometimes inadvertently break old ones. Tests act as guardians, ensuring previously working features continue to function as expected. This is called preventing regressions. Improving code quality. Writing testable code often forces developers to write cleaner, more modular code, which is easier to understand and maintain. Acting as living documentation. A well-written test suite implicitly documents how different parts of your application are intended to work and how they should be used. Boosting deployment confidence. When your tests pass, you can deploy your application with a much higher degree of confidence, reducing anxiety and streamlining your release process. Facilitating team collaboration. In a team environment, tests provide a common understanding of functionality and ensure consistency across development efforts. Laravel's built-in testing features, PHP unit integration. Laravel embraces PHP unit, the widely adopted testing framework in the PHP ecosystem. When you create a new Laravel project, PHP unit is automatically set up and configured for you with a logical directory structure to organize your tests. Tests directory structure, tests feature. This directory is designed for feature tests. These tests focus on larger parts of your application, simulating real HTTP requests to your routes, controllers, and services. They mimic how a user or another application would interact with your system. Tests unit. This directory is for unit tests. Unit tests focus on the smallest testable parts of your code, individual methods or classes, in isolation, ensuring they perform their specific function correctly without relying on external dependencies like a database or HTTP requests. Running tests, you can execute all your tests from your terminal. If you're using Laravel Sail, the command is generally vendor bin sail artisan test. If you're not using Sail, you'd typically run vendor/bin/phpunit, sometimes abbreviated PHP artisan test. Unit tests, testing individual components in isolation. Unit tests are about proving that a specific piece of your code, a unit, works exactly as intended, independently of other parts of your application. The goal is to isolate the component being tested from its dependencies, like a database, external API, or other classes, by using techniques like mocking or stubbing, creating dummy versions of dependencies. When to use. Ideal for testing complex algorithms, helper functions, utility classes, or intricate logic within a single method or class. Creating. You can generate a new unit test file, for example user utility test, using an artisan command like make test user utility test with the unit flag. This instructs Laravel to place the test in the test's unit directory. Conceptual example. Imagine you have a utility class that formats a user's first and last name into a full name. A unit test for this utility would simply call that formatting method with various inputs, e.g., John and Doe, and then assert that the returned value is exactly what's expected, John Doe. This test doesn't need to touch a database or simulate a web request. It just focuses on that single, isolated piece of logic. Feature tests, testing application features from the user's perspective. Feature tests are designed to test the interactions between different components of your application and simulate how a user or an external system would typically use your application. They often involve making actual HTTP requests within the test environment and verifying the resulting behavior and data changes. When to use. Feature tests are perfect for validating your routes, confirming that form submissions work correctly, checking the behavior of your API endpoints, and verifying authentication and authorization flows. Creating. You can generate a new feature test file, for example, post-creation test, using an artisan command like make test post-creation test. By default, Artisan creates feature tests designed to simulate HTTP requests. Conceptual example, post-creation. Let's walk through a conceptual feature test for creating a new blog post. Preparation. The test might first simulate an authenticated user. This involves creating a temporary user record in the test database and then instructing Laravel to act as that user throughout the test. Action. The test would then simulate an HTTP post request to the root responsible for creating posts, e.g. posts. This request would include all the necessary data for the new post, such as a title and content. Assertion, response. After the simulated request, the test would assert properties of the HTTP response. For instance, it might assert that the response status code is 302 found, indicating a successful redirect. It would then assert that the redirection leads to the expected URL, like the list of all posts. Assertion, database. Finally, and critically, the test would assert that the new post was successfully stored in the database. This would involve checking the post's table to confirm a record exists with the title and content that were submitted in the request. For database interactions in feature tests, A common practice is to use Laravel's refresh database trait within your test class. This trait ensures that the database is reset, e.g., by running migrations before each test, providing a clean slate, and preventing tests from interfering with each other's data. Database testing considerations. When performing feature tests that interact with the database, maintaining a consistent and clean state is paramount. The refresh database trait, when used in your test classes, takes care of this by automatically migrating your database at the beginning of each test. You can also specify particular seeders to run with the trait, which populate the database with a predefined set of data that makes your tests consistent. This ensures that every test runs against a predictable dataset, making tests more reliable and easier to debug. Writing simple tests for routes, controllers, and models, recap and encouragement. Routes. Your feature tests effectively test your routes by simulating HTTP requests to them. You're asserting that accessing a URL returns the correct HTTP status code, redirects as expected, or renders the anticipated content. Controllers. Controllers are tested implicitly when you write feature tests that hit specific routes, as the route dispatches the request to the relevant controller method. Models. While true unit tests for models might focus on custom methods within the model, much of the model's Eloquent functionality, like saving, retrieving, and relating data, is confirmed through feature tests that assert database interactions. The initial investment in learning and writing automated tests pays immense dividends in the long run. It empowers you to build with greater speed and fewer bugs, leading to more robust, reliable, and maintainable Laravel applications. As you become more comfortable building features, integrate testing into your workflow from the very beginning. Write a small test before you write the code to make the test pass. This practice, known as test-driven development, TDD, can significantly improve your development process. In the next chapter, we'll shift our focus to the layers above the pure backend: front-end integration and enhancing the user experience. Enhancing the user experience, front-end integration. You've now built a solid Laravel backend, complete with logical features, database interactions, robust authentication, and perhaps even a powerful API. However, a truly modern web application demands more than just data and logic. It requires a dynamic, interactive, and visually appealing user interface. The user experience goes beyond just receiving static HTML. It's about seamless interactions, real-time updates, and engaging presentational elements. This chapter explores how Laravel integrates with various front-end technologies, from its built-in Blade templating to sophisticated JavaScript frameworks and the revolutionary Laravel Livewire. Beyond Blade, introduction to front-end frameworks. While Laravel's Blade templating engine is excellent for generating static or server-rendered dynamic HTML, it inherently operates on the server. For highly interactive elements, real-time updates, and complex client-side user experiences, pure server-side rendering can fall short. This is where modern front-end technologies come into play. JavaScript frameworks libraries. Tools like Vue.js, known for its approachability and progressive adoption. React, a powerful component-based library often seen in large-scale applications. And Alpine.js, a minimal JavaScript framework for adding reactive behavior directly to your HTML, allow you to build dynamic interfaces that run directly in the user's browser. CSS frameworks. To accelerate UI development and ensure consistency, CSS frameworks like Tailwind CSS, a utility-first framework that reduces the need for custom CSS, or Bootstrap, provide pre-designed components and styling utilities. Crucially, Laravel doesn't dictate your front-end choice. It provides the solid back-end infrastructure and then offers flexible tools and integration points for you to pick the best front-end solution for your specific needs. Laravel Mix/Vite, compiling assets, CSS, JavaScript. Modern front-end development often involves tools and languages that browsers don't directly understand. For instance, developers might write styles using preprocessors like Sass or Less, or use next-generation JavaScript features, ES6+, and combine them from many smaller files. These assets need to be compiled or bundled into browser-compatible formats and optimized for efficient delivery. Laravel has long provided robust solutions for this. Laravel Mix, older, widely used. Historically, Laravel Mix served as a fluent API built on top of Webpack, a powerful module bundler. It simplifies common asset compilation tasks, allowing you to easily define steps for compiling Sass-less into CSS, bundling and minifying JavaScript files, versioning assets for cache busting, and copying static assets. You would configure these steps in a Webpack Mix.js file and run commands like npm run dev for development or npm run prod for production-ready optimized assets. Vite newer, recommended. Starting with Laravel 9, Vite became the default front-end build tool. Vite offers an incredibly fast development experience with features like hot module replacement, HMR, which means changes to your front-end code are instantaneously reflected in your browser without a page refresh, speeding up your development loop significantly. Vite is generally faster and simpler to configure than Webpack/Mix for many common use cases. You define your configuration in a vite.config.js file and use commands like npm run dev for development with HMR or npm run build for production-optimized assets. Both Laravel Mix and Vite serve the same fundamental purpose. They take your raw, often unoptimized front-end source code and transform it into production-ready assets, like minified CSS and JavaScript files, that your Blade views can then link to and serve to users. Laravel Livewire, building dynamic interfaces with PHP, avoiding complex JavaScript. Laravel Livewire stands out as a genuinely innovative approach to building dynamic interfaces. Its appeal lies in its answer to a common developer dilemma: how to create highly interactive user experiences without writing extensive or complex JavaScript. The problem solved. Traditionally, if you needed dynamic elements, like a real-time search box, a shopping cart that updates instantly, or a sortable table, you would typically reach for a JavaScript framework. This often meant dealing with framework-specific syntax, state management on the client side, and complex AJAX requests. Livewire aims to simplify this. How it works conceptually: PHP component. You define a Livewire component as a small, self-contained PHP class, usually associated with a Blade view file. This PHP class contains all the logic and state for that dynamic UI element. User interaction. When a user interacts with the UI, e.g., types into an input field, clicks a button, toggles a switch, Livewire's tiny JavaScript footprint on the front end springs into action. AJAX request. This small JavaScript initiates an AJAX request to your Laravel backend. This request contains information about the interaction, e.g., input value changed to X, button Y was clicked, server-side re-render. Your Laravel backend receives the AJAX request. The Livewire component's PHP method corresponding to the interaction is executed. The component's state is updated, and then its associated Blade template is re-rendered on the server. HTML diffing and update. Livewire doesn't send the entire re-rendered HTML back. Instead, it intelligently calculates the minimal difference, a diff, between the old HTML and the newly rendered HTML. Only these small, precise changes are sent back to the browser. DOM patching. Livewire's front-end JavaScript then efficiently updates, or patches, only the necessary parts of the document object model DOM in the user's browser, creating the illusion of a smooth, real-time dynamic interaction. Benefits. Livewire allows you to build sophisticated components with primarily PHP knowledge, significantly reducing the amount of JavaScript you need to write. This leads to faster feature development, a more cohesive code base, mostly PHP, and simpler debugging. It integrates seamlessly with Blade components and authentication, making it a compelling choice for many common dynamic UI needs. Interacting with APIs from the front end, conceptual. While Livewire handles much of the interactivity, for scenarios where you're building a full single-page application, SPA, using frameworks like React or Vue, or a native mobile app, the client-side JavaScript will interact directly with your Laravel backend via the APIs you've built, as discussed in Chapter 8. Conceptual flow, your client-side JavaScript code, using the browser's built-in fetch API or a library like Axios, makes HTTP requests to your Laravel API endpoints. When your Laravel API responds with JSON data, the JavaScript code processes that data and then dynamically updates the HTML and CSS on the user's browser to reflect the new state. This approach provides true front-end back-end decoupling, but requires more dedicated JavaScript development. Using public assets and asset helpers, whether you use compiled assets from Vite/Mix or static files, Laravel provides helpful functions to correctly link to them in your Blade templates. Asset path/to/resource CSS. This Blade helper generates a full, correctly formed URL to a file located in your application's public directory, where all your compiled assets reside. This means your links will work correctly regardless of your application's base URL. Vite. If using Vite. For projects using Vite, this helper automatically handles asset paths and enables hot module replacement during development. It ensures your browser always loads the correct versions of your JavaScript and CSS files, even as they change during development. This chapter underscores how Laravel extends its developer-friendly approach to the front end. Whether you choose to dive deep into full JavaScript frameworks, embrace the simplicity of Alpine.js, or leverage the PHP-first power of Livewire, Laravel provides the underlying infrastructure and tooling for smooth and efficient integration. With your application's logic, data handling, and now interactive user interfaces in place, the next crucial step is to make your application widely accessible. Deployment. Taking your application live. Deployment strategies. You've built your Laravel application, meticulously crafted its features, ensured its quality with tests, and polished its user interface. The culmination of this effort is making it accessible to your users taking it live. Deployment, the process of moving your application from your local development environment to a production server, can seem daunting, particularly for newcomers. However, Laravel, coupled with various specialized tools and services, makes it a manageable and even enjoyable task. This chapter will discuss key pre-deployment considerations, popular hosting options, streamlined deployment tools that automate much of the process, and essential post-deployment practices like monitoring and logging. Pre-deployment checklist, getting ready for prime time. Before pushing your application to a live server, a few crucial steps ensure it runs efficiently, securely, and reliably in a production environment. Environment configuration, env file. Your app.env variable in the env file must be set to production. Importantly, appdbug should be set to false. Debug mode should never be enabled in production environments, as it can expose sensitive application information and stack traces to users. Your production env file must also contain accurate production database credentials, mail driver settings, queue driver settings, and any other environment-specific configurations. Remember, the env file contains sensitive information and should never be committed to your version control system, Git, for example. Optimize configuration, routes, and views. Laravel provides artisan commands to cache your application's configuration, routes, and Blade views. This compiles them into more efficient forms, significantly boosting performance in production. You should run these commands after every code deployment that changes configuration, routes, or views. To cache the configuration, PHP artisan config, cache. To cache the routes, PHP artisan root, cache. To cache the Blade views, PHP artisan view, cache. To clear these caches during development or upon deployment, you can use the corresponding clear command, e.g., PHP artisan config, clear. Run migrations. Ensure your production database schema matches your latest code by running your database migrations. On a fresh deployment or after adding new migrations, execute PHP artisan migrate force. The force flag is vital in production to bypass the confirmation prompt. Install production dependencies. When installing Composer dependencies on a production server, use the nodev flag to prevent installing development-only packages that are not needed in production and take up unnecessary space. Also, optimize the autoloader for faster class loading. Composer install, optimize autoloader nodev. Artisan storage link. If your application uses local disk storage for user-uploaded files or other publicly accessible assets, you need to create a symbolic link from your public storage directory to your storage app public directory. This makes the stored files accessible via the web. Run PHP Artisan Storage link. File permissions. Your web server user, commonly www data on Linux, needs write permissions to the storage and bootstrap cache directories. Incorrect permissions can lead to errors. Generate application key. If it's a completely new environment, ensure your app key in the env file is set. If not, generate a new one using PHP Artisan key, generate. This key is crucial for session and data encryption. Popular deployment methods, where to host your application. Choosing the right hosting environment depends on your budget, technical expertise, and scalability needs. Shared hosting, generally not recommended for Laravel applications. Shared hosting typically offers limited control over server configurations, PHP versions, and command line access, which Laravel often requires for artisan commands and Composer. While technically possible with some providers, it's usually a frustrating experience. Virtual private servers, VPS/cloud providers, recommended for control and flexibility. Providers like DigitalOcean, AWS EC2, Google Cloud Platform, GCP, Linode, and Vultr offer virtual machines with full root access. This gives you complete control over your server environment, allowing you to install and configure everything precisely to Laravel's requirements. Nginx or Apache, PHP, Composer, database. The trade-off is that you are responsible for server setup, maintenance, security updates, and monitoring, which requires system administration knowledge. Platform as a Service, PaaS. Recommended for simplicity and scalability. PaaS solutions abstract away much of the underlying server management. You deploy your code, and the platform handles the infrastructure, scaling, and maintenance. Laravel Vapor. Laravel's official serverless deployment platform. Built on AWS Lambda, Vapor offers unparalleled scalability, a pay-per-use billing model, zero server management, and seamless integration with other OS services. It's ideal for high-traffic applications that need to scale automatically, and for developers who want to avoid server upkeep entirely. Other general-purpose PaaS options include Render, DigitalOcean App Platform, Heroku, though Heroku's free tier has limitations, and Envoyer discussed below. These services simplify deployment significantly, allowing you to focus more on your application code. Laravel Forge and Envoyer, automated deployment tools. For developers who want the control of a VPS cloud provider, but also desire automated, streamlined deployments, Laravel offers powerful services. Laravel Forge. Forge is a server provisioning and deployment service. You connect Forge to your chosen cloud provider, DigitalOcean, AWS, GCP, etc., and it automatically provisions and configures your server with all the necessary software for a Laravel application, Nginx, PHP, MySQL/PostgreSQL, Redis, Composer. Once the server is set up, you connect your Git repository. GitHub, GitLab, Bitbucket, and Forge handles automated deployments. When you push changes to your repository, Forge can automatically pull the latest code, run Composer installs, execute migrations, compile front-end assets, and clear caches, significantly simplifying the deployment process. Laravel Envoyer. Envoyer is a zero-downtime deployment service for PHP applications, often used in conjunction with Forge or on any server. Traditional deployments often involve a brief period of downtime while new code is uploaded. Envoyer deploys your application to a new, separate directory, and once the deployment is complete and passes health checks, atomically switches a symbolic link to point to the new code. This ensures a seamless transition without interruption to your users. It also provides instant rollback capabilities, allowing you to revert to a previous working version if any issues arise with the new deployment. Envoyer is essential for mission-critical applications where uninterrupted service is paramount. Manual deployment steps for conceptual understanding. Even with powerful automation tools, understanding the manual steps is beneficial. Here's a high-level overview of what happens during a typical manual Laravel deployment to a VPS, provision server, get a clean Ubuntu or preferred OS server. Install dependencies. Install Nginx or Apache, PHP with required extensions, Composer, and your chosen database, MySQL/PostgreSQL, and other services like Redis. Clone repository. Connect to your server via SSH and clone your application's Git repository. Configure env. Copy env example to env and fill in all sensitive and environment-specific variables for production. Install Composer dependencies. Run Composer install, optimize autoloader no-dev. Set file permissions. Ensure the web server user has proper read-write permissions for storage and bootstrap cache. Run migrations. Execute PHP artisan migrate force. Link storage. Run PHP artisan storage. Link if using public storage. Generate application key. If not already set, PHP artisan key generate. 10. Optimize caches. Run PHP artisan config, cache PHP artisan root, cache PHP artisan view, cache 11. Web server configuration. Configure Nginx or Apache to serve your application by pointing its document root to the public directory within your project. 12. Cron job for scheduler. Set up a cron task on the server to run Laravel's task scheduler, CD path to your app, and in PHP artisan schedule, run dev/null2 and 1 every minute. Monitoring and logging. Once your application is live, proactive monitoring and robust logging become vital. Laravel's logging. Laravel has excellent built-in logging. Configure it to send critical errors to external services, like a log management platform. Error monitoring. Services like Sentry or Bugsnag capture and notify you of application errors in real time. Uptime monitoring. Tools like Uptime Robot or Status Page alert you if your application goes down. Performance monitoring. Solutions like New Relic, Blackfire, or Laravel Horizon for queues help you identify performance bottlenecks and resource usage. Successfully deploying your Laravel application is a significant milestone. Whether you choose the hands-on control of a VPS, the streamlined simplicity of Vapor, or the automation offered by Forge and Envoyer, understanding the underlying principles ensures a smooth transition from development to a live, production-ready web application that serves your users reliably. In our final chapter, we'll explore advanced Laravel topics and chart a path for your continued growth as a Laravel developer. Beyond the basics, advanced topics and next steps. Congratulations! You've journeyed from simply setting up your Laravel environment to understanding its core architecture, interacting with databases, handling user input, securing your application, building powerful APIs, writing comprehensive tests, and even deploying your creations to the world. You now possess a strong foundational understanding and practical skills in Laravel development. However, Laravel is a vast and continuously evolving ecosystem. Many powerful features extend its capabilities far beyond what we've covered in the foundational chapters. This final chapter will briefly introduce some more advanced features and concepts that you'll likely encounter as your applications grow in complexity and scale. It will also provide essential guidance on how to continue your learning journey and become an even more proficient and well-rounded Laravel developer. Queues, offloading long-running tasks for better performance. In web applications, certain tasks can take a long time to complete, such as sending a bulk email newsletter, processing uploaded images, generating large reports, or integrating with external services that might be slow to respond. If these tasks are performed synchronously, meaning the user has to wait for them to finish, they can significantly slow down your application's response time, leading to a poor user experience or even timeouts. Queues are Laravel's elegant solution to this problem. They allow you to defer the execution of time-consuming tasks to a separate background process. Instead of causing delays for the user, you dispatch these long-running operations as jobs to a queue. Dedicated queue workers. Background processes constantly listening for new jobs, then pick up these jobs and process them asynchronously. This leads to faster response times. Your web server can immediately send a response back to the user, improving perceived performance. Improved user experience. Users don't have to wait for the lengthy process to complete. Increased reliability. If a background job fails, it can often be retried, preventing data loss. Laravel provides a unified, expressive API to work with various queue drivers, including Database, Redis, Amazon SQS, and others, making it easy to integrate even complex background processing. Broadcasting, real-time communication, WebSockets. In modern web applications, static content often isn't enough. Users expect real-time updates, like instant notifications, live chat messages, collaborative document editing, or dynamic dashboards that update without a page refresh. Laravel's broadcasting system provides a clean way to push server-side events to client-side JavaScript applications using technologies like WebSockets. Here's the conceptual flow. Event trigger. Something significant happens in your Laravel backend, e.g., a new message is posted, a user's status changes. Event broadcast. Your Laravel application broadcasts an event to a driver, like Pusher, Ably, or a self-hosted WebSocket server. Client listen. On the front end, your JavaScript, often using Laravel Echo, a JavaScript library that integrates seamlessly with Laravel's broadcaster, listens for these specific events over a persistent WebSocket connection. UI update. When an event is received, your JavaScript immediately updates the user interface, providing that desired real-time experience without requiring the user to refresh the page. Broadcasting opens up a whole new dimension of interactivity for your Laravel applications. Notifications, sending various types of notifications. Laravel's notification system offers a flexible and unified API for sending notifications to your users across various channels. Instead of manually crafting emails, SMS, or Slack messages for different events, Laravel streamlines the process. You define a notification as a simple PHP class. Within this class, you specify how the notification should be delivered for each channel by defining specific methods, e.g., to mail, for email to Slack, for Slack to database, to store it for an app display. Laravel then handles the delivery mechanism. Notifications can also be queued, ensuring that sending them doesn't slow down your application's response. This system promotes consistency and reusability when informing users about important events. Packages, exploring the Laravel ecosystem of third-party packages. One of Laravel's greatest strengths lies in its vibrant and extensive community-driven package ecosystem, all seamlessly integrated via Composer. Instead of reinventing the wheel for common functionalities, you can leverage thousands of high-quality, open-source packages. Examples of powerful packages you might encounter. Admin panels. Packages like Laravel Nova or Filament allow you to rapidly build beautiful and functional administration interfaces for your application's data. Full-text search. Laravel Scout integrates your Eloquent models with powerful search engines like Algolia or Melee Search, providing lightning-fast search capabilities. Payments. Laravel Cashier provides an expressive, fluent interface for managing subscription billing services like Stripe or Paddle. Debugging tools. The Laravel debug bar is an invaluable tool for debugging your application during development, providing insights into queries, views, routes, and more. Leveraging these packages for common problems or recurring needs accelerates development significantly. Always ensure to check a package's documentation, community support, and maintenance status before integrating it into your project. Artisan commands, creating custom command line utilities. We've already seen how indispensable Laravel's built-in artisan commands are for daily development tasks. However, you can also create your own custom artisan commands to automate application-specific tasks. For example, you might create a custom command to import a large dataset from a CSV file, perform a complex data cleanup operation, generate a periodic report, interact with a third-party API from the command line. You generate these commands using an artisan command itself, then you define the command's signature, how it's called, and its logic within the handle method. This allows you to centralize and automate repetitive operational tasks. Task scheduling, running recurring tasks with ease. Many applications require performing scheduled tasks, such as sending daily summary emails, cleaning up old data, or fetching external information at regular intervals. Traditionally, this is managed using a server's cron job scheduler, which can be complex to set up and manage, especially for multiple tasks. Laravel's Task Scheduler provides an expressive and programmatic way to define and manage all your recurring tasks directly within your Laravel application. You define your schedules, e.g. hourly, daily, every Monday at 5 p.m. in your application's app/console/kernel PHP file using a fluent, human-readable API. On the server, you only need to set up a single cron job that runs Laravel's schedule, run artisan command every minute. Laravel then automatically checks your defined schedules and executes the appropriate tasks. This simplifies task management significantly, keeping all your scheduling logic within your codebase. Maintaining your Laravel application, updates, security. Staying current is critical for the long-term health and security of your Laravel applications. Regular updates. Follow Laravel's release cycle. Minor versions often bring new features and bug fixes, while major versions introduce significant changes. Keeping your application updated ensures you benefit from the latest improvements and security patches. Security bulletins. Stay informed about security advisories. The official Laravel website and community channels, like Laravel News, regularly publish information about potential vulnerabilities and patches. Code quality and static analysis. Tools like PHP or Fan analyze your PHP code for potential errors, type mismatches, and other quality issues without actually running the code. Integrating such tools into your workflow vastly improves code reliability. Where to go next? Your path forward. This book has provided a robust entry point into the world of Laravel development. To deepen your expertise and continue your journey, official Laravel documentation. This is, without question, the single most comprehensive, accurate, and up-to-date resource for Laravel. It's meticulously maintained and covers every aspect of the framework in detail. Laracasts. Created by Jeffrey Way, Laracasts is an unparalleled resource for video tutorials on Laravel, PHP, JavaScript, and related web development topics. Its learn-by-example approach is highly effective. Laravel News. Stay updated with the latest news, tutorials, package announcements, and community insights from the Laravel ecosystem. Experiment and build projects. The best way to learn is by doing. Challenge yourself to build more complex applications, integrate different features, and solve real-world problems. Don't be afraid to break things and fix them. Build a personal project from scratch, contribute to an open-source project, or tackle unique challenges. Community engagement. The Laravel community is incredibly welcoming and active. Join the official Laravel Discord server, participate in forums, attend local meetups, or follow Laravel developers on social media. Learning from and connecting with others is invaluable. Dive deeper. Explore more advanced topics that pique your interest. Custom service providers, event listeners, abstracting complex business logic into actions or commands, polymorphic relationships in Eloquent, advanced testing patterns, like mocking HTTP requests, advanced deployment strategies, and continuous integration, continuous delivery. CI/CD, pipelines. Laravel is not just a framework. It's an entire ecosystem built on the principles of developer happiness, expressiveness, and elegant code. By continuing to explore its depths and staying engaged with its vibrant community, you'll find yourself capable of crafting increasingly sophisticated, performant, and impactful web applications. Happy coding!